Okay, so this is Unit 6, Learning Objective 20. This is the last learning objective. Whoop, whoop. And this is to label and interpret a phase diagram. So the phase of a substance is determined by the temperature and pressure. A phase diagram is a graph of temperature versus pressure that shows in which phase a substance exists under the different conditions. So, the phase diagram for water. The way that this is set up is that you have pressure on the y-axis and temperature on the x-axis. Now, there are 3 regions on a phase diagram that represent solid, liquid, and gas. And I'm going to label this as X, this is Y, and this is Z, just on this so that I don't have to write all over this X, Y, and Z. The smallest part is the solid, the middle part is the liquid, and then the very bottom part down here is the gas phase. Now, also on the diagram, so there are 3 curves that represent the changes of state. So AB here, right here, so line AB from here to here, is your change of state from a solid to a gas, or a gas to a solid. And this would be your sublimation deposition line. So sublimation, you're going to go from a solid to a gas. And for deposition, you're going to go from a gas to a solid. Line AD, so from here to here, you're going from a solid to a liquid or a liquid to a solid. So this is going to be your melting, freezing line. So again, AD is melting, freezing. So we're going from a solid to a liquid or from a liquid to a solid. And then the last curve is A to C. Now, A to C is your, we're going from a liquid to a gas or a gas to a liquid. So this is the vaporization condensation line. So condensation, we're going from a gas to the liquid, and then for vaporization, we're going from the liquid to the gas. Okay. Now, you have a couple of points. On the graph that you need to be aware of, point A, right here in the center, where the 2 lines kind of hit one another, is the triple point. This represents the temperature and pressure at which all 3 phases simultaneously exist. So if you could hit this point for water would be both a solid, liquid, and gas at that point. A negative slope of line AD So again, this is the freezing, melting line, indicate that the solid floats in its liquid. So a positive slope would indicate that you have your solid sinking in your liquid. So if you have this, solid sinks, and in this case, solid floats. So solid floats, solid sinks. So point C, which is this point way up here, point C represents the critical point. And this indicates that the temperature and pressure above which there's no distinction between the gas and liquid states. So the critical point C, so this is C up here. This is the point at which there's no distinction between the solid, the liquid, and gas states of matter. So this would be my critical temperature here. This would be my critical pressure here. That's the temperature and pressure above which there's no distinction between the gas and liquid phases. So the critical point is where the substance becomes a supercritical fluid. And again, this is where there is no distinction between the gas and liquid phases of matter. Now, from this, we can also determine the melting point and the boiling point. Now, we call this the normal melting point or the normal boiling point. And this is the temperature found at 1 atmosphere of pressure. So our normal pressure is 1 atmosphere. So the normal melting point or boiling point is the temperature found at 1 atmosphere. So then if we look at this particular graph, we can find the normal melting point would be right there going down, so 0 degrees Celsius. And then the normal boiling point right there at 100 degrees Celsius. So these are my normal melting point, and this is my normal boiling point. So this was learning objective 20, our last learning objective, woohoo, which was to label and interpret a phase diagram.